Thank you very much, Susanna. And yes, as you said, we're now diving into the process design, which may be a new term for many of you, because when we speak about safe by design, usually people are dedicated to trying to change the material. But if you click to the next slide, I will show you that actually risk is a combination of hazard and exposure. And if we present it as being, let's say, the lion being a hazardous animal, and you expose yourself to that animal, there will be a risk. But the fact that risk is a component of two different elements, we also feel that there's two ways of trying to mitigate the risk. Namely, the first one is trying to lower the hazard, as just been presented by Mustafa. But if that fails, or if that's not possible, we also would try and lower the exposure, and ultimately do the same, also try to lower the risk. And basically, this is not just my opinion, but also a lot of toxicologists, and one that lived a long time ago already expressed that basically every material, every chemical is poisonous, but it depends on the dose whether it's a danger to your health. So next slide, please. So of course we have to look at the hierarchy of control, and I would definitely plea for trying to mitigate the hazard of the material as much as we can. So try to eliminate or substitute the hazards from occurring. So trying to change the lion into a harmless kitten. And that's what we call safe by material design, as just presented by Mustafa. But as I said, if that's not possible, or whether if we, for instance, need these materials for an energy transition, or used in pharmaceuticals or cosmetics or any other products that we really need, then there's still an option to lower the exposure levels and try to implement process designs which will also lower the exposure and hence the risk. And that's what we call safe by process design. Then in the hierarchy of control, there's the last resort that can be used to ultimately save the human being from being exposed, which is called personal preventive equipment. But that's not to be considered today, because that's really not a by design issue, but that's more like a last resort to save people. And as already presented by Carlos in his opening presentation, therefore we use in the SPD for Nano project both toxicological properties as well as exposure properties, and my presentation will be solely focused on exposure. Next slide, please. So in this SBD for Nano project, we focused on the safe by process design in this work package. So what we did in this, and what I will present today, is the collation of existing and newly generated data on dustiness release and exposure throughout the full life cycle of a product's use. Then, based on these data, we developed a fit-for-purpose nano-specific exposure model to do an assessment of your exposure for a current situation. Then we developed a safe by process design specific module to help the user in selecting the right mitigation strategy. And together with that, also already expressed by Carlos in the opening presentation, is a cost analysis to also enable and facilitate the user in making the most cost-benefit decision. And of course, I'm presenting here the result of it. This was a collaborative effort of a lot of partners in the project. Next slide, please. So as I said, we started off with a collation of existing and newly generated data. This was a combination of existing data, so the information that was already available on release and exposure of a wide variety of different nanomaterials in a wide variety of different activities, scenarios, and processes. And together with that, we also harvested from our stakeholders within the project, but also outside the project, the needs for additional risk management measures or exposure measurements or exposure controls. And I will not go into the details of all of these figures, but you see that it was quite an extensive work. And if you want to know more, please visit our website or read the deliverables of our project. Next slide, please. More importantly, based on these data gap analysis, we were able to identify the gaps in exposure data that we knew of, and we were able to fill these data gaps. So within ITENA, they had a test chamber in which we could mimic exposure situations, perform measurements, feed these measurements into the eNanoMapper database, use a lot of these data together with the existing data to build an exposure a quantifier model, and then based on that build a computerized IT tool which can be used to assess your exposure. Next slide, please. So as I said, we in totally harvested 131 individual exposure measurements. We fed these data into to an exposure template that was developed in a previous project called Gracious. We use different measurement instruments to measure the exposure levels, which all measure different size ranges and all different characterizations of the particles in the air. And based on that, we built a conceptual model to assess the exposure based on determinants that we feel influence the exposure level. Then we performed the statistical analysis called Bayesian modeling and machine learning models to identify exposure multipliers in addition to a baseline task exposure to derive as an output a quantitative measure of exposure to nanomaterials during a certain scenario and activity. As you can see in the right down corner, we were also able to identify the uncertainty around that estimate by implementing a 95% confidence interval. Next slide, please. Then, of course, to enable users to actually use this model, we built an IT tool based on different activities, different questions that were answered. The user is able to generate an exposure estimate for the current situation and compare that to a hypothetical situation that's based on safe by design alterations. So you can actually make a modification to your process, and then in the comparison page you can see what the influence of that change in your exposure scenario or your process will do to the exposure estimate for that scenario. Next slide, please. And this will actually facilitate first of all a good fit to the exposure data. So it's not, let's say, only by expert judgment, but also underpinned with measured data, as I just explained. There's sufficient explanation and guidance provided in the tool to guide users to making the right SBD selections. There's visualization of the results to make a comparison between different scenarios. And we wrote a scientific publication about this if you want to know more about the scientific details that underpin this model. And more importantly, and that will be shown in the next presentation by Ralph, is that this model is built into the e-infrastructure that was the final result of the SPD for Nano project. Next slide, please. So in addition to this exposure assessment tool, which assesses the exposure for a certain scenario, for a certain nanomaterial, we also identified and made a release hotspot scan, which helps the users by asking a few simple questions of creating an overview diagram of all the releases during the life cycle of that specific product. The user can make use of default values that are derived from the ECHA SPERC, so the environmental release categories, but users can also enter their own findings and then make let's say, user-friendly and a fit-for-purpose assessment. There's also a database with release factors underneath that, so users can actually select from that database to use that, and then ultimately there's a dynamically built-up visualization of the workflow, which is presented in the next slide. So the end result of this release hotspot scan is identifying all the different releases throughout your production phase, use phase, and end of life phase, and therefore you get a nice overview of where the most of your release in your process takes place, and therefore it also gives you a good indication where you can actually mitigate or manage these releases, so to lower the release to either environmental compartments or indoor air compartments, which may cause human exposure. This tool is freely available on our Diamonds web platform of TNO, but it's also made available in the e-infrastructure that will be shown in a minute. Next slide, please. No, this was just to indicate what we did. In addition to inhalation exposure, there's not so much research done on dermal exposure modeling of nanomaterials, and therefore we felt that in addition to the inhalation exposure model that I just presented, we also like to give some sort of a decision tree based on simple questions, whether dermal exposure is an issue for your situation and whether you need to actually assess dermal exposure. So it will not provide you with a quantitative estimate of dermal exposure as you would get for the inhalation exposure, but it gives you an indication whether you should consider dermal exposure in addition to inhalation exposure. Also, this tool, and this is still under development, but will be made available soon, definitely before the end of the project, and it will also be added to the infrastructure so that people can use it in the SBD for Nano infrastructure. Next slide, please. So then what I told you up till now is the exposure assessment part. So analyzing the exposure of the current situation, but of course, as I started off with, you would like to make changes to your process to lower your exposure, reduce your exposure, and manage the exposure. And therefore, in addition to the NEQ model, so the nano exposure quantifier on the left-hand side, we added the Safe by Design module that comprises of several factors and components that I will show you in the coming slides. So first of all, we analyzed the risk management measures effectiveness using the exposure control efficacy library. We had ETENA had a computational fluid dynamic model implemented and used, which can also be used by the users of the system. Then we made e-cards that was mainly done by CEA as a partner in providing guidance to the users on which risk management measures they can use to lower the exposure. And then finally, we had an exposure directionality assessment to also guide the users for the right SBD strategy. Next slide, please. So first of all, the e-cards. So the e-cards are meant to provide information on different risk management measures to take in the hierarchy of control that I started off this presentation with. So we identified 9 risk management measures and 13 different subcategories, which are listed on this slide. And in the next slide, you will see which information is comprising of these different e-cards. So these 22 e-cards in total have the structure as you can see on the left-hand side. So they have a definition or a text of what the risk management measure is. In this case, it's about local ventilation system. So there's a description of what it is. There's an explanation of which level of hierarchy of control it's in, and there are suggestions for best practices that can be used in using local ventilation system. Then there are links to relevant documents, and there's a set of criteria which are identified at the middle of this slide. First of all is the complexity of the implementation of these risk management measures, so whether they are ready to use, whether there's additional development required, or whether they use maintenance, etc. Then, of course, the effectiveness, and you can already see that this is a bandwidth of the different effectiveness values. So it's not just one value, but based on how you use it or how you implement it, the effectiveness can change. Then the target group for which the management measure is implemented. So is it for workers, for consumers, or to protect the environment? Then the lifetime of the risk management measure. So is it for single use, like a mouthpiece or face mask, or whether you can use it for multiple years or over the full process lifetime. And then, as already was indicated by Carlos, there's also the cost assessment, because of course a full-blown ventilation system, as you can see on the left-hand side, will cost you more to implement than just handing out face masks. And if you want to know more, there was a presentation given at the NanoSafe conference this year, and we did this in collaboration with the Sabina project. Next slide, please. So this is what the e-cards look like in more detail. So you find all the information that I've just told you. So on the left-hand side, you see the overall e-card for local ventilation system. And on the right hand side, you see the e-cards for the enclosing hoods, which is just one type of local ventilation system that can be used. So if you want to know more, all of these e-cards are available on our Diamonds platform or in the e-infrastructure that will be presented by Ralph later. Next slide, please. So then, as I mentioned, TNO developed a computational fluid dynamic model, which was based on a definition of parameters or variables that were used. Then they generated experimental data, used mathematical models to build up the CFD model that you can see a visualization of on the left-hand side. And this model was validated by using the case studies in the work package 6, so the case study development in our project. And then, of course, in the end, it was also implemented in the e-infrastructure. And if you click once more, Stella, you'll see let's say a screenshot of what it currently looks like, and people can look it up on the website and use it. Next slide, please. And then finally, the cost analysis was done, and it was done in coherence with the work that Mustafa just showed, because it's not just the costs for the exposure management measures, but also, of course, to the risk management measures to lower the hazard. And this all led to a cost-integrated economic scoring system, which is implemented in the tool and which will be shown in a moment. Next slide, please. So to summarize what we've done in trying to save by process design, so to lower the exposure, we started off with identifying data gaps and harvest all the information that was available to try and lower exposure. We did experimental work to fill these data gaps and to provide workplace studies to measure exposure. Based on all of these data and knowledge and expert judgment, we build an exposure-driven modeling framework that allows the users to assess the exposure for their situation. If you want to know more about the release hotspots of your product throughout the full product value chain, you can use the hotspot scan. And if you feel that in addition to inhalation exposure, dermal exposure may also be of an issue, we are developing, which is almost finalized, the SabiDerm module that's added to the exposure model. And then, of course, the most important part is the nano-specific safe by process design module as integrated in the e-infrastructure, which either gives you information by the e-cards on which risk management measures you can use, the effectiveness of the exposure control measures using the library that we have, the CFD model that I just showed, together with the cost estimation, and hopefully all of this information will guide the user towards making the right decision in trying to lower the exposure to nanomaterials. And I think this was my last slide. Thank you very much for your attention, and if there's any questions, I'm happy to answer them or to answer them in the breakout session that we have later on. Thank you.